Hello students, so welcome to my new video. Today we are going to calculate, suppose if there is an electric dipole which is being placed in an uniform electric field. So in that case, what is going to be the torque which is acting on the electric dipole? Okay, so those who don't know what is electric dipole, please check out my last video. I hope you know what is electric dipole and what is an electric field. Okay, so let's start. Let us consider that we have an electric dipole. So this is the electric dipole. Those who don't know what is electric dipole, these are a pair of, you can say, equal and opposite charges. So this is a pair of equal and opposite charges. So this is minus Q, this is plus Q. So this is an electric dipole, fine? So this is the midpoint of the dipole, O. The length of the dipole, suppose it is 2L. I have already explained in my previous video why we consider the length to be 2L. If you want, you can consider the length to be L also. So this is an electric dipole which is being placed in an uniform electric field. Suppose there is an electric field all around the dipole and the dipole is being placed inside the electric field. Now electric field intensity has a direction, electric field is a vector quantity, so electric field will be having a direction. So this is the external electric field. Remember, this is the external electric field. So suppose this is the electric field intensity which is acting from this direction to this direction. If you want, you can consider the opposite direction also if you want. Okay, so this is the uniform electric field. Now remember, uniform electric field. Now that means the electric field intensity all around the dipole is same, which is equal to E. Okay, which is equal to E. That means the electric field intensity all around the dipole, normally electric field intensity, it depends on the distance. But over here we have considered an uniform electric field, which means that all around the dipole, the electric field intensity is same. Remember, this is the external electric field, okay? And in this external electric field, the dipole is placed. So what is going to happen? So there is an external electric field and inside the external electric field, the dipole is placed, okay? Now, you see, always I say that electric field intensity acts from plus charge to minus charge. Okay, so E acts from plus charge to minus charge. That means if the external electric field is acting in this direction, that means on this side there must be a plus charge, okay, and on this side there must be a negative charge. Remember, this plus and minus has no relation with the plus and minus of the electric dipole. This is an external electric field inside which the dipole has been placed. Okay, so this is a plus charge, this is a minus charge. Suppose if the electric field intensity is acting in this direction, if you want, you can consider the opposite direction also. Here I have considered that the electric field is acting from the left to right. So here must be a plus charge, here must be a minus charge. Okay. One more thing, if there is an electric field and inside the electric field, if you place a charge, then the charge experiences a force. That force is given by QE. Okay. So if there is an electric field whose electric field intensity is E, okay, remember E is the electric field intensity. Electric field, it's basically the electric field intensity, okay, and in the electric field, inside that particular electric field whose electric field intensity is E, over there if you place a charge which is Q, then the charge is going to experience a force. How much force? The force is given by Q into E, okay. Now see, so this is a dipole. So what is going to happen, you see? Over here, this is a negative charge, okay? This is minus Q I have considered. And over here I said that the external, there must be somewhere a plus charge must be there. Okay, so plus and minus. This plus charge is going to pull this minus charge in this direction. Okay, with a particular force. Suppose this is F1. Fine. Why? Because you see, over here I have considered there must be a plus charge since the electric field is acting from this direction to this direction. So here there must be a plus charge. Over here of the electric dipole there is a minus Q. So this plus is absolutely going to pull the minus Q towards it, because the plus and minus, they attract each other. Okay, so how much will be the force of attraction? So force of attraction on minus q. Okay, force of attraction on minus q. So that is going to be F1 will be equals to, here I have given the formula, that is QE. Okay, F1 is going to be QE. Okay. What is the direction? It acts in the opposite direction of E. Okay, so F1 equals to Q into E. You see, E is acting in this direction. F1, this force is acting in this direction. Okay, so this is going to act in the opposite direction of E. Okay, now this charge is also going to experience a force. Okay, you see, this is plus charge. Okay, and as I say, if this is the direction of the electric field intensity or the electric field, you can say, then over here there must be a plus charge, here there must be a minus charge. You see, this plus and this plus, they are going to repel each other, or you can say this plus and this minus, they are going to attract each other. Anyway, you understand, in both the cases you will see that this charge is going to experience a force in this direction. If, okay, so this charge plus and minus, they are going to attract each other, or you can understand in another way also, this plus and this plus, they are going to repel each other. In both the cases, in whichever way you understand, in both the cases you will see this charge is going to experience a force in this direction. Okay, so force of, I can say, repulsion on plus q. Okay, force of repulsion on plus q, that is equals to F2 equals to, this one also will be equals to q. Okay, force is q because the charges are same, so both the charges are going to experience the same force. Okay, q. So this force is going to act in the same direction of E vector. Okay, so this is going to act in the same direction of E vector. You see, F2 is going to act in the same direction of E vector. Fine. So ultimately what happens, you see, if this is the dipole, okay, if this is the dipole, okay, this is the dipole, this is minus q, this is plus q, this is the direction of the electric field intensity. This charge is getting pulled on this side, okay, and this particular charge is getting pulled on this side. So the electric field, the external electric field, what it is doing, it is pulling this charge on this side and it is pulling this charge on this side. So ultimately what is going to happen, the dipole is going to rotate. Okay, so those who are watching, I hope you also know what is a torque. Okay, so torque is getting produced in the dipole, and the dipole slowly it is going to rotate inside the electric field. Right, because the electric field, what it is doing, it is pulling this charge on this side and it is pulling this charge on this side. So it is, in a way, it is turning the electric dipole. So the electric field will, what it will do, it will turn the electric dipole, a torque will be produced, and this dipole is going to turn in this manner. Okay, in the, you can say in the clockwise direction. If you consider the opposite direction of electric field intensity, it will be in the opposite direction, right? So the dipole is going to turn in this manner. So this is the dipole. It is going to turn in this manner. Now what we are going to find out, we are going to find out how much torque is acting on the dipole. That we are going to find out. Okay. Now what is the expression for torque? Okay. So here I am writing, so the dipole will turn in the clockwise direction. So the dipole will turn in the clockwise direction. Why it will turn in the clockwise direction? A torque will be produced on the dipole. Torque will be produced on the dipole. So torque will be produced on the dipole due to what? Due to the electric field. Due to the electric field. So the electric field is going to produce a torque on the dipole, right? And how much torque the electric field will produce, that we are trying to find out. Now the expression for torque, okay? So torque is written in this way, tau. The formula for torque is either force, any one of the force, What is a torque? Basically, those who don't know what is a torque or what is a couple, it forms a couple. Okay, this is basically a couple. Now, what is a couple? Couples are two equal and opposite forces which are not acting along the same direction. So, if this is the electric dipole, this is one force QE, this is another force Q into E. QE and QE both are equal forces but acting in the opposite direction. But they are not acting along the same line. One force is acting on this side, another force is acting on this side. So this forms a couple, due to which the dipole is going to rotate inside the electric field. So what is the formula for a couple, you can say? So that is force, any one of the force, because both the forces are same, you see, F1 is QE, F2 is also equals to QE. So both the forces are same, either force into perpendicular distance between the two forces. So either force into perpendicular distance between the two forces. That is the formula for a couple. Okay. So this is one force, this is another force. This was the dipole. Okay. This is, suppose this one is point A, this is point B. Suppose this is point A, this is point B. Fine. So this is one force, F1, this is another force, F2. Now, which is the perpendicular distance between the two forces or between the line of action of two forces? This one. So this is the perpendicular distance between the line of action of two forces. Okay. So if I draw a perpendicular over here, this one. Okay. Suppose this is A, this one is B. And here I am considering N. Okay. So Bn becomes the perpendicular distance between the line of action of two forces. And now it is very easy, just you have to find out what is the length of BA. Okay. Now those who know vectors, you will be understanding what is the length of, or how to find out the length of BA. See. So here I can write F into BA. Okay. F into BA. Okay. Now how to write BN? You see, AB. This is AB. This is BN. Those who know vectors and those who have an idea about the components of a vector will be knowing. If this is AB, okay, then this is the horizontal component. AN is the horizontal component, and this one or this one is the vertical component. Okay. So BN I can write AB sin theta. What is theta? This angle. This angle is theta. Okay, this particular angle is theta. Theta is the angle. Okay, remember, theta is the angle with which the dipole was initially placed with the electric field. Okay, that angle is theta. The dipole was initially placed with an angle with the electric field, and then the dipole is going to rotate. So that particular angle is theta. Right? So you know, Bn is the vertical component of AB. Okay, Bn is the vertical component. So this one also you can see the vertical component, or this one also you can see the vertical component. Anyone, both of them will be the same. So vertical component, if this is theta, vertical component becomes AB sin theta. Okay. Now, so F into AB. Now what is AB? The length of AB, you see, it is 2L. So 2L sin theta. So F into 2L into sin theta. Now we can put the value of F. Now see, F1 and F2, both of them are the same forces. So any one we can put. So QE into 2L sin theta. So QE into 2L into sin theta. Now this one we can write Q into 2L into E sin theta. Now see, Q into 2L. What was Q into 2L? That was electric dipole moment. Q into 2L. Q into 2L is electric dipole moment. And remember, in which direction electric dipole moment works? Electric dipole moment works from minus Q to plus Q. Okay, so this is the direction for electric dipole moment. This is the direction of electric dipole moment, minus Q to plus Q. Okay, so our expression becomes tau equals to PE sin theta. This is the expression, or for, you can say, the torque which is acting on the electric dipole. Okay, so this is the torque acting on the electric dipole. Okay. Now, how long this torque is going to act? You see, if this is the electric dipole, this is the electric field upon acting on this direction. This particular charge is getting pulled on this side, and this particular charge is getting pulled on this side. So ultimately, the electric field is going to turn the dipole. Now, once the dipole becomes straight like this, once the dipole becomes aligned, or we say aligned with the electric field, then you see this particular charge is getting pulled on this side, and this particular charge is getting pulled on this side. So with equal forces, okay, with equal forces. So ultimately, the dipole is not going to rotate after this. So this becomes the equilibrium position. Okay. So once if this is the electric field, once the dipole becomes like this, minus Q plus Q. Once the dipole becomes like this, after that it is said that the dipole comes in an equilibrium position with the electric field intensity. Okay. But before that, as long as it does not happen, the electric field is going to turn or rotate the dipole. Okay, and a couple, or you can say torque, will be acting on the dipole, whose expression is P into E into sine theta. Now, torque is a vector quantity, so if you want to express this in vector, you can write it this way. It is P cross E, cross product. Okay, so the expression for the torque which is acting on the dipole is E cross E. We know A cross B is AB sine theta, so P cross E will be PE sine theta. Okay. So this is the torque which is acting on the electric dipole when it is placed in an electric field, uniform electric field. Now, what will be the maximum torque? Maximum torque, condition for maximum torque. Here I am doing condition for maximum torque. So tau equals to PE into sine theta. Now, what is the maximum value of sine theta? Okay, the maximum value of sine theta is 1. Okay, that is the maximum value of sine theta. So sine theta equals to 1. That means sine 90 degree will be equals to 1. You can see. So if sine theta is 1, so sine 90 degree is 1. Okay, that means therefore theta equals to 90 degree. That means when the dipole is placed in this way. So when the dipole is, this is the electric field, this is the direction of the electric field. So if the dipole is placed in this way, then theta becomes 90 degree. In that condition, the dipole is going to experience maximum torque. Okay, so in that condition, the dipole will experience maximum torque. So if theta equals to 90 degree, and in that case, how much torque it is going to experience? So tau max means the maximum torque is going to be P into E, because if theta is 90 degree, then sine 90 will be equals to 1. So this will be the maximum torque the dipole is going to experience. Okay, so that was the expression for the torque which is acting on an electric dipole when it is placed in a uniform electric field. Okay, so that was all for today's video. If you like the video, please like and subscribe. If you have any questions, please let me know. Thank you.